Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So I hope you guys understand from our previous video. Okay, so this time I would like to discuss with you guys the last subtopic for week number 5. We call as an equation of the normal to the curve. Okay, I just want to highlight one more thing. There is one question, actually one example from our slide. Okay, so this is the slide. Hopefully this appear on your video. Okay, slide number 35 for week number 5, application of differentiation. Okay, the question asks, write the equation of tangent to the curve. Actually, soalan ni sebenarnya dia tanya equation of normal. So cancel the tangent, change to normal. But the solution is correct because the solution discuss about equation of normal, but suddenly the question asks for tangent, so it's totally wrong. It's a mistake actually, so please excuse my mistake. Okay, so therefore please do the correction. Change the tangent to normal. Okay, back to the slide. Okay, so now equation of normal. Equation of normal is very simple actually. The normal to a curve is the line that is perpendicular to the tangent. This is the keyword. Perpendicular to the tangent to the curve at the point of contact. Okay, based on this diagram. Okay, let's say this is your curve. Okay, along the curve there are so many of tangents. Tapi katakanlah di sini equation of tangent kita. It can be anywhere lah. Okay, tapi by using the definition of normal to the curve, dia kata normal to the curve is perpendicular line to the tangent. Okay, katakanlah ini equation of curve awak ada tangent. So soalan minta awak soalan minta awak normal to the curve. So kat mana location normal? Over here, dia perpendicular to the tangent. So this is tangent, this is normal. Okay, alright. So apa kita boleh buat dengan these two properties? Actually, the relationship between tangent gradient and tangent gradient and normal gradient is the product of both equal to -1. When you multiply both m of tangent multiply dengan m of normal equal to -1, because both are perpendicular to each other, or m normal equal to -1 over mt. -1 over gradient of tangent. Okay, that is the understanding lah. Tapi macam mana nak cari equation of normal? Equation sama lah sebab dia straight line. So still you need to use y equal to mx plus c. Okay, alright. So I'm using this example from exercise 16.08. So the question, write the equation of normal of each of these curves at given point. Tapi I would like to solve for A. So that you can try for the rest of the question. Okay, so now okay, so if y prime equal to m of tangent, okay, so therefore m tangent multiplied by m normal equal to -1. So m normal equal to -1 over m tangent lah. Dah highlight tadi. Okay, so now we come up with the solution. This is the understanding here. Okay, so first thing first, identify the y prime, the first derivative. So differentiate x squared become 2x, differentiate 3x become 3, differentiate negative 4 is 0. So y prime equal to 2x plus 3. Okay, so at point 1, 0, so y prime become 2 times 1 plus 3 equal to 5. So m tangent equal to 5. Therefore, m normal negative 1 over 5. Okay, so substitute the same process macam tangent tadi. Substitute m normal equal to 1 over negative 1 over 5, and the coordinate 1, 0 into y equal to mx plus c. Substitute lah. So 0 equal to your m is negative 1 over 5 times 1 plus c. So c equal to 1 over 5. Therefore, y equal to negative 1 over 5x plus 1 over 5 is the equation of normal. It's very simple. Okay. First thing first, identify the y prime, because the y prime will give you the m4 tangent. Substitute the coordinate in order to dapatkan the value, and then by using the multiplication between m tangent and m normal equal to negative 1, you play around with the equation, substitute the value, therefore you akan dapat m for normal. After that, substitute both together, substitute m normal and also the coordinates into the equation y equal to mx plus c to dapat c, baru boleh dapatkan equation. Alright, so question number 18. Where does the tangent to the curve, which is y equal to x cubed plus 4x squared minus 2 at the point 1, 3, cut the curve again? Meaning, there ada dua point of intersection between tangent and also the curve. Ada dua. Okay. I give you the idea. If we wanted to sketch the graph, your graph should be like this. Hopefully they will appear on your screen right now. Okay, so this is the red color is the original curve equation, but the blue color is the equation of tangent. Okay, now I click on the screen to get the point of intersection. So you can see from here the equation, okay, this is the intersection. This is the intersection number 1. Okay, let me zoom in for you. Okay, this is the point of intersection number 1. Mana dia? Okay, this one. 1 and 3 is the first coordinate of intersection. Okay, I zoom out. Okay, to prove there is another point of intersection between the blue curve, the blue straight line, and also the curve. This is the another one. If you use the decimal, boleh dapat straight away lah the coordinate. Tapi how to prove by calculation? Okay, so back to the question here. Right, so now first thing first, you have to differentiate the curve. Differentiate x cubed become 3x squared. Differentiate 4x squared become 8x. Differentiate negative to 0. Okay, at point 1, 3, this is your m actually. At 1, 3 equal to become 3 times 1 squared plus 8 times 1. So m equal to, press your calculator, dapat 11. So this is the equation of the gradient. So substitute m equal to 11 and the point 1 and 3 into y equal to mx plus c. Kenapa kena dapatkan? Because kita dapatkan equation of tangent first lah. So substitute, you will have 3 equal to 11 times 1 plus c. So you akan dapat c equal to negative 8. So therefore equation there become 11x minus 8. Okay, now you have to equate equation of tangent to with the equation of the curve again. Okay, I put it here. So y of tangent equate to the y, the original curve. So 11x minus 8 equal to x cubed plus 4x squared minus 2. So therefore simplify, you akan dapat x cubed plus 4x squared minus 11x plus 6. Okay, press your calculator, solve. You akan dapat x equal to negative 6 or x equal to 1. Yang ini given. Because dia dah kata dia cuts at 1 and 3. At the point 1, 3. So we know at x equal to 1. Okay, this is the first point. Which is the first point of intersection between the tangent and also the curve. Right, so what we need to do is with negative 6 over here. At x equal to negative 6, substitute into yt lah paling mudah, because yt is the shortest equation compared to the y. So therefore y equal to 11 times negative 6 minus 8. So y equal to negative 74. So therefore another coordinate or another point of intersection is negative 6, negative 74. Alright. Moving on. Okay, so this time is question from number 19, 16.08. Okay. Read the question first. Write the coordinates of the point of intersection of the tangents to the curve of y equal to x squared minus 5x minus 6 at the points where the parabola cuts the x-axis. Okay, so basically this is the diagram. Okay, this is the x-axis and the parabola passing through or cuts the x-axis. So you can see there are two coordinates of x. First coordinate and the second coordinates. Okay. Now they wanted to know the point of intersection between two tangents. Okay. So let's say kita letakkan dua tangent. You can put anywhere as long as the cuts the curve and also there are point of intersection. There is a point of intersection between two tangents. Okay, so this is the curve lah basically. What is the coordinate over here? They wanted to know the point of intersection. So what we can do is, number one, kena identify the coordinate of your x dahululah. So at x-axis y equal to 0. Therefore 0 equal to x squared minus 5x minus 6. So you akan dapat sini x equal to 6 or x equal to negative 1. So dapatlah dua koordinat, which is 6 and 0. Another one, negative 1, 0. Mana datang 0 ni? 0 is from the x-axis. Okay, kita kata at x-axis y equal to 0. Okay, so dapatkan equation of tangent dahulu lah. Okay, so m equal to y prime, which is y prime is differentiate the equation of curve. Differentiate x squared become 2x, differentiate negative 5x is negative 5, differentiate negative 6 is 0. Okay, so at coordinate of 6, 0, m equal to 2 times 6 minus 5, m equal to 7. Ni pula at point of negative 1, 0, m equal to 2 times negative 1 minus 5, kita dapat m equal to negative 7. So you dapat dua gradient over here ya. So therefore substitute m equal to 7 and the coordinate of 60 into y equal to mx plus c. Sama juga untuk the second case. Substitute m equal to negative 7 and the coordinate of negative 1, 0 into y equal to mx plus c. So apa you dapat sini ialah y, 0 equal to 7 times 6 plus c. So therefore c equal to negative 42. Therefore y equal to 7x minus 42 is the first equation of tangent. Over here 0 equal to negative 7 times negative 1 plus c. So you dapat c equal to negative 7. So the second equation of tangent is negative 7x minus 7. Apa nak buat dengan dua ni? Equate lah. So katalah ni T1, this is T2, this is tangent number 1, this is tangent number 2. So equate dua-dua ni. T1 equal to T2. So 7x minus 42 equal to 7x minus 7. So therefore you will have over here is 1, 4. X equal to 35. So x equal to 5 over 2 or 2.5. The first coordinate. Second coordinate, substitute, bukan second coordinate, substitute to get the y. So y equal to 7x minus 42. 7 2.5 minus 42, you akan dapat sini ialah negative 24.5. So as a conclusion, the point of intersection, therefore the point of intersection is 2.5 is negative 24.5. That's it. Okay, last but not least, question number 20. Okay, the graph shows the parabola given by the equation. It is not drawn to scale. What is the distance between the vertex, top of the parabola over here, and the point where the normal to the curve at negative 1, 0 and 7, 0 intersect? Okay, if you notice, okay, T1 and T2 ni actually not the T1, this is actually the normal, normal number 1, normal number 2. Sebab dia dah kata sini at the point where the normal to the curve, normal ya. Okay, so kena dapatkan dahululah equation of tangent, baru boleh dapat equation to normal. Okay, so y prime dahulu, differentiate, dah dapatkan gradient of tangent. Negative 2x plus 6. So at x equal to negative 1, y prime become negative 2, negative 1 plus 6 is equal to 8. So ini ialah equation for tangent number 1. Okay, at x equal to 7, y prime equal to negative 2, 7 plus 6. So y prime equal to negative 8. So this is M for tangent number 2. Di sinilah basically. Okay, now kita dapatkan m for normal number 1 equal to negative 1 over m for tangent number 1. So negative 1 over 8. So substitute m normal number 1 equal to negative 1 over 8 and the point of negative 1 0 into y equal to mx plus c. Sebab kita nak dapatkan equation normal the first equation normal yang di sini okay, so 0 equal to negative 1 over 8 times negative 1 plus c. So therefore c equal to negative 1 over 8. So therefore y normal number 1 is negative 1 over 8 x minus 1 over 8. Second, m for normal number 2 equal to negative 1 over m tangent number 2, negative 1 over, tadi m number 2 is negative 8, so 1 over 8. So substitute m equal to 1 over 8 and the point of 7, 0, okay, into y equal to mx plus c. So 0, m kita 1 over 8, this is 7 plus c. So you have c equal to negative 7 over 8. Therefore, y normal number 2 equal to 1 over 8x minus 7 over 8. So baru kita boleh equate dua-dua equation ni. So kita equalkan lah. yn1 equal to yn2 because kita nak dapatkan point of intersection. So negative 1 over 8x minus 1 over 8 equal to 1 over 8x minus 7 over 8. So negative 1 over 8x minus 1 over 8x equal to negative 7 over 8 plus 1 over 8. So sini akan dapat negative 1 over 4x equal to negative 3 over 7. Therefore, you dapat x equal to 3. Okay, how about y? So substitute x equal to 3 into, let's say, negative 1 over 8. The first equation of normal over there. So you akan dapat sini y equal to negative 1 over 2. So therefore the point of intersection is 3 negative 1 over 2. Okay, now you dah dapat dua coordinate. Okay, I make a summary over here. As a summary, the first coordinate is 3 negative 1 over 2. So kita kena dapatkan the second coordinate. So nampak second coordinate. Kalau you tengok based on the graph just now, the lines, okay, the lines at the maximum kan. So this one y prime equal to 0. So the second coordinate lies over here, which is y prime equal to 0. So tadi kita dapat y prime equal to negative 2x plus 6. So at y prime equal to 0, 0 equal to negative 2x plus 6. So you dapat sini ialah x equal to 3. How about y? So substitute back lah into the original equation here. At x equal to 3, y3 equal to negative 3 squared plus 6 times 3 plus 7. So equal to 16. So the second coordinate. Is 3 and 16. So you dapat dua coordinate baru you boleh dapatkan the length ataupun the difference. And dia minta kita what is the distance between the vertex dan juga the point of intersection. Okay, so therefore